Good morning, everyone.
Good morning.
All right, we got 18 people, 6 missing. All right, give me a minute. Let me take all these things out. Okay. Let me take the attendance first, then we'll talk. Isabel.
Here.
Okay. Samuel. Samuel? No? Okay. Samuel is absent. Kiland. Kiland? Absent. Kaesh.
I'm here.
Kaesh?
Professor. I'm here, Professor.
Okay. Kaesh, you missed a couple of classes. Better catch up. Suchi.
Here, Professor.
Dialed in. Dialed in. Ira.
Here, Professor.
Okay. Angel Hernandez.
I'm here, Professor.
All right. Shomik.
Present, Professor.
Right. Kyle. Kyle. Okay, Kyle, I see you. Ken.
Here.
Collins. Collins.
Here.
All right. Alex.
Here.
All right. Janat.
Here.
Satendra.
Here.
Adam.
Here.
Adam. Yeah.
I'm
Okay.
here.
Adam Ortiz. Mr. Ortiz. Henry. Henry. Is your name Henry? Alejandro.
Here.
Tanvir. 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 No, I don't see you. See, you are actually, in fact, absent. Benjamin.
Yeah.
Ilya.
Here.
Robert. Robert? No. Robert Schifrin. No. Carlos.
Here.
All right. Rita.
Here.
So quite a few people are not here today. I'm going to call the name that people are absent. Probably they came in and or maybe I missed them. One is Robert, Tanvir, dialed in, Kiland, Samuel. Okay. Okay, before I start, I want to talk about one thing that I was checking. Let me see, test out, login, login. What happened with the login? Stuff. Super Explore login training coursework. Okay. Let me go through this. Okay. So, couple of people, let me see what's going on. Jannat, did you sign up with Test Out or CompTIA? No. Oh, you did. Yes. Okay, so you're fine. Let me take out my comment. Okay. Henry, not in CompTIA. Henry. Did you sign up with CompTIA or test out? Henry? Henry, are you here? Okay, let's see if he's here or not. I see you. Henry, are you here? Okay, Henry, maybe you stepped aside. I don't see your name in test out, meaning you did not sign up. That means you're not doing your homework. And it is important that you have to do it. Everybody has to do homework. If you do not, one criteria is that you have to finish the homework before taking the midterm. So test out, I do not grade right away. So if you're a little bit late, it's fine. You're not going to lose points. But the rule is that you have to do every week. And then the major rule is that if you don't finish it by whatever is assigned by midterm, then you will not be able to take the exam. That's the school rule. So that one is, so Henry, please sign up. And then Ilya, let me
I will
see
start
what's
now.
going on with you. Oh, Ilya, let me see what's going on with you.
I signed up, but I didn't purchase the course yet.
Yeah, I see that you signed up. Okay, so let me check what is going on. You signed, okay, so let me see, it says no. Yeah, yeah. So what happened? You signed up, but you didn't purchase it, right?
Yes.
So you need to,
I
so
know.
that means you won't be able to do the homework.
Yes, next week. I mean,
Yeah,
tomorrow or after tomorrow.
yeah, do that because,
All right. Yeah.
within
Got
a
it.
few weeks, you're gonna have midterm, right?
Mm-hmm. On
Yeah,
15th, right?
okay. So I check these things time to time. So you going to sign up, purchase it, and Henry, you did not sign up. Neither you sign up nor purchase. You need to sign up and then you need to purchase because you're not in test out in Kia. What is it called? Kia CompTIA. So and Ilya has signed up but not purchased. And Janat, I see that you're fine. Okay. So these two person need to take care of test out. All right. So anybody has any question from TCP/IP version 4 that we covered in last 2 weeks? That one you will today is gonna have quiz on everything you did in last 2 weeks. So if you did the homework, the homework and everything, you should be fine. It takes time, so you're going to get 30 minutes. I'll tell you when you take the quiz. But that's what it's about. But make sure that IP version 4 you review before midterm, before final, before interview process, because those information are really, really important. Even if you start working, those things will help you. Those are the fundamental, and what you have learned is in terms of IP version 4, from beginners to intermediate knowledge, you have solid intermediate knowledge. So, if you tell your, interviewer that, yeah, I'm certified, hopefully you'll get certification. And then I know about IP version 4. And then he said, really, let me ask you. And whatever he asks you, I'm pretty sure you'll be able to answer. And he will be impressed that, yes, actually you did, even if you don't get the certificate. Okay, so let's see, schedule what we're going to do. Let me share my screen. Share my screen. Let me share everything so that we can, everything is not good. Okay, so slide. No, not from the beginning. So we did week 1, no. Week 1 we did, week 2, week 3. Week 4 we had quiz 1 and we finished IP version 4. We submitted the lab. I didn't grade IP version 4. I usually grade together. So today and tomorrow I'm going to finish up 2 lab. Okay. And test out I do not every week, but I'll probably one of these days. I'll do that. Okay. Today is this one. So module 4, so you're going to do 4.7, 4.5 to 4.7. 4.5 to 4.7. What is the star saying is that 4.7.4, 4.7.8 is really important, right? But what is your homework is 4.5, 4.6.
Looks like this.
Right? This is your homework.
That's what I said, but I think there's a slide.
Somebody,
We'll go through.
speaker is on, microphone is on. Colin, your microphone is on?
Yeah, it is.
Okay.
So what I was saying, wait, so you're saying there's no quiz this week?
No, there's a quiz. Quiz 2
You can-
today. Quiz 2 is all about IP version 4 that you did in the last 2 weeks. Your homework is 4.5 to 4.7. Okay, so what I'll do is that. Oh, what did I do? What did I do? This one. Okay. So, and then we'll be creating LAN with router. That's going to be lab. I'll talk about it. Never worry about the next week. Okay. So take a screenshot and I have to minimize it. Let me do this. Homework. It's going to be this. And when it says star 4.78, DHCP and DNS, this is an important, that's all I'm saying. But this is your Zoom. So chat, I'm going to put, this is your homework, is going to be this homework. Okay, test out module, this one. So I put it in the chat as well. And also please, it's in the chat, but please take a screenshot if needed. Any question? Any question? Today's week 5. The module 4.5, 4.6, 4.7 is your test out. We'll lecture on IP version 6. That's the future, right? And we'll cover enough to understand the basic level IP version 6. They have implemented IP version 6, but that's not used widely. That quiz is going to be on IP version 4. Okay. If you have any question, you let me know. This is your test. What is this? So let's go back to lecture content. So we did 4 and then 5. That's what maybe 5A, 5B. There's no 5B, I think. Command line interface. Did I cover that? I did actually. March 1st, February. I have to look into it. Okay. So IP version 6, it's going to be 10 and 5. 920, that's fine. And I'm going to put ended to be 12. That's fine. 31st. So you should be able to see your lecture. Just want to make sure that it is. Okay. You should be able to see the lecture. It's a week 5A, so don't worry about the week or something. Sometimes they do not exactly follow because we changed the content, and sometimes we do not update exactly which weeks it fall into. So don't worry about why it says week 5A or 5B, but it just today, but today's lecture is IP version 6. So I'm going to lecture that, and then your lab is going to be packet tracer. We're back to packet tracer and lab again. So we'll be doing packet tracer. So packet tracer subnetting, we did that. Packet tracer, create a simple network using packet. Is that this one? No, router. So I'm not assigning this. This is too simple. RAB, you see that now I have 6. So I skip 5. So don't worry about the lab number. Whatever is you're assigned to do, just do it. Okay. So this is going to be available today, which is 10/5. No, not 25/5. And this due date is next week. So 10/5, not 5. This is going to be Saturday, 11. Okay, and that is the same. 10/5. No, 11. Okay, so your lab is also set, but we'll check again. So this is going to be lab 6, even though with today's lab week 5. Okay. Okay, so you should be able to see it. Okay, any question? Any question? If anybody has any question, don't hesitate to ask. So far, you guys are doing all right. I mean, is it too hard? I mean, too easy? What is it, anybody? It's not too much work. It's not something that you'll like suffer to understand. It's just, if you read through, if you do it, I think it's quite obvious. But this kind of course just actually give you a job. That's the beauty of it. Okay, IP version 6. So let me see if I have. How many do I have IP version 6? I had PowerPoint, yeah. I have too many. Let me see. Let me open up one so that I know which one I have attached. So this one, what is? Is that what it is? Oh, this is a lab. I'm looking at the lab to look at the lecture. The lecture material. IP version 6, 5A, PPT. Let me see which one. I'm trying to take the. This one has 31. Create a unique interface. 31 lectures. So that means 31 slide. Intro summary. Oh, maybe it's summary. Let's summary. Yeah, 31. Yeah. All right. Check it again. Yes. Okay. Let me share my screen. Okay. Yeah. Content save. Where did the lecture go? Yeah, this one. Okay. Oh, okay. So, slideshow. Okay, I'm sharing my screen. If you don't see it, you let me know. Okay. So we covered IP version 4. That we had 32 bits, 32 binary bits, right? And they're separated by 4 octet, right? 4 octet, that means 8 bits each. 8888 gave you 32 bits. That was IP version 4. But then they came up with IP version 6. Why is that? Because they ran out of all the IP addresses. You see that? ARPANET begins in 1970, right? .com started 1990s. And you see that in 2010, IANA gives out last IP version 4. So they ran out. That's 15 years ago. Then they came up with, private IP address and all those subnetting and all those things. So, so they started doing private IP addresses. That's what it's called. They came up with short-term network address translator that uses private IP address. That's how they started doing that, because they feel that there has to be a way to accommodate that, at least for now. So they started doing research on IP version 6. They call it RFC, request for comments. And then in 2000, they say, yep, we need to have something called IP version 6, right? because they knew it's going to run out. And 2010, they ran out. But the research is complete in 2000, so they already have the whole idea in place. So now question is that they have the whole IP version 6. Question is that will they replace it? They're actually concurrently using IP version 6, even though IP version 4 is the one they're referring to. But if you see that they're also using IP version 6. Okay. I don't think it's mandatory, but they're doing it just to make sure that everything looks fine. So that's the idea. Simply they ran out, so they came up with a new idea, but by the meantime, they use private IP addresses. Okay. These things we covered, right? That in 80s, you had IBM, DC, they had their own IP system, networking system. But then TCP/IP came in 90s, and that it became de facto. So they're all using IP version 4. In future, we'll be using IP version 6, right? So you see that? They're using both, right now they're using both TCP/IP and, IP version 4 and IP version 6, but they're actually using IP version 4 to communicate, and IP version 6 just there. Internally, they're also communicating, make sure it looks good. 2020, and the question is that in 30, would it be totally IP version 6? Probably they'll get rid of IP version 4. But right now, it's still they're using it. So what we have is let me see what it says. 4-byte version, class flow, payload. Okay, this one should not matter at this time. So IP version address is 128 bits long. Instead of 32 bits, it's 128 bits. And source address is 16 bytes, and destination address is 16 byte, not bits. So now they're using 32 bytes. So if we divide 120 by 32, that means you have 4 bytes, right? 4 bytes each, right? So 4 bytes, 4 bytes, 4 bytes, 4 bytes, that's 16 bytes for the source and 16 bytes for the destination, altogether 32 bytes. But in bits, it's 128 bits. Okay. So now we know this 120, but 128 bits, writing out is difficult, right? You have to write 120 zeros and ones. So they said, no, let's do it in hexadecimal instead of binary. Writing this address in binary would be a problem. So they said, let's do it in hexadecimal format. Okay. So one hexa, we know that one hexa is 4 bits, right? 4 bits. So using one hexa for 4 bits of binary number. And if you have 4 bits, right, then the combination is combination 2 to the 4, right? That will give you 16 possibilities. 2 to the 4 give you 16 possibilities, right? 2 to the 4 equals 16. So hexa can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? That gives you, which is 0 to 15, right? This is a 16 possibility. So every hexa can be represented by either 0 or 1 or 2, 3, 4, 5, 6, 7, 8, 9. And then A, B, C, D, E, F. If there's any G. 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Not A, B, C, D, E, F. So any hexa can be one of these 16 possibility, 0 to 9 or A to F. Okay. So now it becomes easier, right? Look at this one, it becomes easier. So now look at this. You have 4 bytes, right? 1, 2, 3, 4 bytes. So 4, 4, 4, 4, 4, 4, 4, 4. How many? 1, 2, 3, 4, 5, 6, 7, 8. 8 bytes gives you 8 times 4 is 32, right? 4 is 32. 32 bytes, so 32 hexadecimal. So if you write it out, you have to write out 32 hexadecimal. Well, that's better, right? In IP version 4, we had 8 times 4, 32. Now we have also 32 bytes in hexadecimal, but instead of octa, now you have 4. Right? I don't know what it's called. I think it was a name. So for each, but in each time it's separated by colon, not period, not 128.3. This is 2, 3, 4, 5 colon 1, 1, 1, 1 colon 2, 2, 2, 2 colon. That's how they write out. So far, so good. These are just rules. Okay. And you can have 0 to 9 or A to EF. Now you can shorten it and we'll look into it. The second one, you see that they didn't write out 32 hexa. And this one even less. So you can shorten it and we'll look into it in next few slides. But so far we know that you got 32 hexadecimal. Each of them goes from 0 to A and A to F. And there are 16 possibility. And for hexa, I know there's a name. For hexa, after 4 hexa, you put a semicolon. So each 4 hexa is separated by colon, not semicolon, colon, okay? It's just some rules. We're going to cover IP version 6, very basic one, because, you know, it's still they're using IP version 4. Still there analyzing, investigating everything IP version 4. And still you'll be working on with IP version 4, but your boss may want to know and then put you in an IP version 4 team. And if you know the principle and basic, then you'll get it. You're like, okay, I understand. So they, you know, the way they design, they basically prefix tells you where it belongs. If it starts with 2001, it goes to North America. Erin, if it starts with 2ABC, then it's Afrinic, belongs to African IANA version of Africa, right? And so on. And you can have Australia and blah, blah, blah. So that's one. And then you'll have the next would be 2 sets up 4 bytes would belong to the ISP, you know, who the ISPs are. And the last one, actually last half, goes to the company. I believe it's the last half. Here it says last 3. Whatever. They go to the that belong to the company. Right? So they look at it and they say, oh, that belongs to that particular ISP. So, right, this 2 sets of byte. Right? So don't, you know, think about this too much. It's just they are separated. Right? 1, 2, 3, 4, 5, 6. Okay, so this is not totally cleared in a matter, but looks like there are 3 bytes, 3 sets of bytes is these belong to company. So let's take it that is true, and 2 of them belongs to ISP. So just know that, every set gives you some information. Okay. So there's a question, not my favorite slide, but there's a question in your midterm or quiz. So that's why this slide is here. So first hexadecimal. 2 or 3 originally, all not otherwise reserved today. So this is called global unicast. Global unicast addresses that work like public IP address. The organization that needs IPv6 addresses asks for a registered IPv6 address block, which is assigned as a global routing prefix. After that, only that organization uses the address inside that block of address. That is the address that begins with the assigned prefix. So it says that if it starts with 2 or 3, it's like a public IP address, global unicast, right? And then it says if it starts with FD, then it works like a private IP address, somewhat like private IP address. That multiple organizations use the exact same address with no requirement for registration, right? So you don't need to register if it starts with IP FD. And if it starts, the prefix starts with FF, oh, what happened? No. Oh, FF. So multicast is FE, no, is it FF? FF. It is used for multicasting. That means not broadcast, but multicast. A group of address will be using this this type of IP address starts with FF, right? And link local is basically for it's to communicate with the host router, right? So these are basically used for the local machine. It's almost like a MAC address. Now this one is just so that you know it's there. I mean, this is something you'll forget or not discuss in detail, but just know that the prefix, whatever it's there, it means something. It can mean whether it's a public IP address, starts with 2, 3. Private IP address starts with FD. For multicasters purpose, it's FF. That if it communicate within the LAN, like MAC, then starts with FE80, right? So this is not widely discussed here, but so that you know that it's there, okay? So this slide, the earlier slide and this one, it just know that it's there, okay? Okay, now the idea is the same. You have the address of the sender, right? This is an IP address. It's shortened. You see, now you have 2 colon, right? We'll talk about it. But this is an IP address, IPv6. And you have gateway IP address, same thing. And it's going to this interface, right? So same idea, right? You have IPv6 packets, and you have the header, trailer. It's all the same. you have the routing table, the way the routing table is created, and you have the sender's address and receiver address. Everything is same. I'm not sure it does use MAC address, probably not, because MAC address is replaced by something else, but we'll see. We'll see. But idea is the same, that use packets, use header, and use footer, and everything is the same as IP address. It's just the IP address itself is 32 hexadecimal instead of 32 bits. That's all it's saying. Right. It comes here, the router capsulate, it looks at the next address and it knows where the next address is. It encapsulate again, then send it to the next router. It could be here or it could be here. It will send it to the next router. The process is the same as IP version 4. Right, open up, this is coming from this address sender. Where is it going? To this address, in California. And then, so what is the next type router? Is probably this or this. And then it closes it, sends it. Okay. Oh, see, that's what he's saying. De-encapsulate, re-encapsulate. It's not only IP version 4, it's the same idea as IP version 6, same thing, right? You have the packet, you have the header, footer, all those things. These are all, protocol. I mean, the header and footer, the way we are showing it and we cover it, it's a high level ideas, but they use a lot of headers. Header increases. There's so many protocol comes in, error correction, error detection, there's that. Sometimes your header, footer altogether is as much as the packet itself, the real data itself. So high level data link control. Okay. So there is also something called subnetting. It can happen here. Okay. Okay. So you see that the idea is the same. Okay. That's all he's saying. This is the routing table, the same thing. It's coming from this one, the sender. Where is the output? S000. See that? It says that this is already connected here, so you don't have to say it. So it's going out S000. So back to, remember I said in the beginning, you write FA and then suppose 0-1, it means 0 is the module and 1 is the number, 1 is the port number. And FA stands for Fast Ethernet. If the port is serial port, then you can have a serial port. It's a Fast Ethernet port. Then you start with S. And if it's a serial port, then there are 3 of them. See 000. So last 2 is the same. Second one is the module. Third one is the port number. And first one is the, I think, chassis number of something else. Module, and then port, and the first one, this one is chassis or something. That's how they define serial port. So you'll see 3 of them instead of 2. And serial starts with S, otherwise it starts with FA is Fast Ethernet, and GI is Gigabit Ethernet, right? So that's why you see S000. This is useful information because you'll be using it. So in the routing table, it goes this one, and that's where is the next router, R2, so it's going to go there. So anytime a computer loads, sends information, this routing table is filled. So next time it doesn't have to communicate with this, who are you, where are you going, blah, blah, blah. Instead, it knows that this guy, it's going through this one, right? So you have the routing table for faster communication. These things happen automatically. It means serial interface. Oh, this is slot one. So okay. So 0 is the slot. First 0 is the slot 0. I mean, it could be 1, 2, 3. It could be 1/2/0. So first one is slot. Second one is the card or module, and third one is the port. The last one is always the port number. Okay. You can have the subnet. We are not going to cover subnet, but they have a concept of subnet in IP version 6 as well. Okay, idea is the same, but calculation is different because you have 128 bits or 32 hexadecimal. Right. Okay. This one you have to. This is another slide that you learn and then you'll forget. But it's in the. See, I put it in red. That means they are important for your quiz or your midterm. So this is something you'll easily forget, but maybe some of them you'll remember. RFC. So three. Okay, so RIP next generation. RIPNG. RIP generation is a protocol intended to allow routers to exchange information. Will you remember it? Probably not, but at least if you read it, if you can try to put it in your head, then it's fine. It's just a protocol. Routers they use to exchange information. Fine. This is important because see, OSPF is open shortest path found or find. In version 3, in version 4, I'm sorry, in IP version 4. In IP version 6, it's called OSPF version 3. It's called OSPF version 3 in IP version 4. So this is similar to OSPF. OSPF we use for IP version 4 and OSPF version 3 is for IP version 6. So what does it do is that it looks as defined in RFC24. So what it does is that it looks for shortest path. So remember, like, I don't know, I wrote something. So this one, right? So, from R1 to R2, and it could have, let's say your final destination is this one or this one. And it's possible that it's not good. So it will try to go this way and then this way, right? And then this. Or you could go, there could be another link from here to here, right? So it hops so many times in order to go to, let's say, even next state. If you go to New Jersey, and if you ping something, you'll see that you can do trace RT command. Maybe we'll do it. And then you'll find out there's hopping, giving you like 6, 7 different hops to even nearby states. Each time is hopping, meaning each time it's going through a router, one hop. Let's say this is 1 hop, 2 hop, 3 hop. So that particular protocol, OSPF, finds the shortest path. If it is broken, it will go this way. And if this is broken, then it will go this way, but it will find the shortest path in terms of, bandwidth and hopping and all those things. So if you find out as a network engineer that it's taking too long, the hopping is too many hops, and you feel that something is wrong because you check that this router is actually good, the connection is good, but it's not hopping through that. So your protocol is, the software tool is bad. So what can you do as a network engineer? You don't go and rewrite the code. You just reinstall that OSPF. So that's why you need to know these things. Right? Something is, not hopping correctly, it's not giving you the correct as far as you think. So you reinstall. That's what they do, right? You're not coding. That's different people that do it. I remember actually going through the algorithm for OSPF in my graduate school. I don't know how far. I remember we went through the algorithm, maybe we coded something, but as a network engineer, all you have to do is that if it is wrong, then you replace it. So you have a bunch of these things. This is important. So it's red, right? And EIGRP, I didn't like the name. Version 6, Enhanced Interior Gateway Routing Protocol. This is Cisco's own. Cisco owns the right to the protocol used for automatic routing decision. Okay. So it automatically decide which way to go. So if you're not to do that, this guy has to use this one and maybe other protocol too, if you want to automatically decide your path. Because OSPF will give you the shortest path. See, this guy needs help from this guy, right? EIGRP version 6 needs help from OSPF. So can you remember this? Probably not, but at least you know that there's a protocol, if you can remember EIGRP version 6, that uses for automatic routing decisions fine. OSPF version 3, you should remember because I got it red. MPBG, see, I've been teaching every week, every semester, and I don't remember. MPBGP4, multi-protocol, this one, version 4, this is RF, was created to be highly extendable. IPv6 support was added to BGP version 6.4 through one such enhancement. See, I don't know even what it does, right? I don't know even what it does. So forget it. This is another one that you'll be using it, NDP. NDP is same as ARP in IP version 4. It's called Address Resolution Protocol. If you put the ARP, then and then IP address, it'll give you MAC address and vice versa. ARP and RARP, reverse ARP, will gives you MAC address. Or if you do RARP, then MAC address will gives you the IP address, right? You want to know what is the MAC address of that particular device. Or you want to know, I know the MAC address, what is the IP address of this device? So this ARP does that in IP version 4. In IP version 6 is NDP, Neighbor Address Protocol. So it gives you everything about your neighbor, right? And you'll be using that. So these two are important. NDP, that information about your neighbor, the IP address, who's connected, and all those things, more information than ARP. You need to know that. You need to know SPF. All right. And the rest of them, read through, you'll forget. Question? No question. So I don't need to tell you that. You guys already know this is either first semester or a high school thing. Hexadecimal, right? So 0 is nothing but 0000. Then 1 would be 0010, 2 is 001, and you can go on, right? And 9 is 1001, and then You go A, B, C, D, E, F. Now you have 16. The last one is 1, 1, 1, 1, right? So you have 4 binary. 2 to the 4 gives you 16 possibilities. A, B, 1 to 9, and A to F. And if you write it out in 4 digits binary, then this is how it is, right? So when you say hexa 2, this is actually 0010. And hexa A is represented by 1010. Even you're writing out A, then it's converted, your machine language understand it as 1010. It doesn't know what A is. It converts, you have another program converts A to 1010. Right? So this is easy, right? You should not have any question, but if somebody has a question, let me know. If you think that or forgot. But it's a 4-digit hexa. 4-digit binary, you're writing in hexa. So that's how you write it out. A lot of things are write it out in hexa, which is represented by 4 digits. Even your MAC address is represented by hexa, and each one is 4 digits binary. Yeah. Each character, whether 0 to 9 or A to F. Now these days, you can just type it out in your Google and it will tell you what it is. But you got to understand also. As an engineer, you should understand. 2 basic rule lets you or any computer. Now, how do you shorten an IPv6? You have 128 bits, but you're not writing out in 120 bits. You're writing 32 hexadecimal separated by 4 hexa and a colon, right? They call it quarter, now I remember, okay. So instead of octa, now a quarter, because you have 4 hexa. Okay, so you can shorten it. You don't have to write out. So it's inside each quarter, so that means you have 4 digits, right? So inside each quarter, now 4 hexa, not 4 hexa, right? So that's a quarter of 4. Oh, I wrote it for hexadecimal. Remove the leading 0. Zeros on the left side of the quarter. Anything you have 0 on the left, you can remove it because we know that there should be 0. In the 3 positions of the left node, at this state, a quarter will leave a single 0. So any leading 0. So if you have 0, 0, 1, 1, that will represent to just 1, 1. If you have 0, 0, 0, 1, or 2, that will represent just 2. But what about if you have 0, 0, 0, 0? You cannot just remove everything. So you have to leave at least 1 0. That's what it says. If you have all 0, you have to leave at least have 1 0. Otherwise, we don't know really. Right? So you are shortening it now. We're learning how to shorten because we were lazy now. We don't want to write it out even 32 hexa. We said, make it more even easier. So that's rule number 1. Rule number 2, find any string of 2 or more consecutive quarters of all hex zeros. If you have 2 and more consecutive quarters and all zeros, if you have a scenario of like that, then replace the set of quarters with double colon. If we just put a double colon, we know that this colon means fill the rest with all zeros. And it will make sense to you more when we do some practice. But basically, it's saying that you have 0, 0, 0, 0, and then 0, 0, 0, 0. All I have to do is just write double colon. And I can understand, system can understand, oh, this means that many zero because you already have some hexadecimals, right? So you're supposed to have 32 hexadecimal. And if you have 16 hexa and then colon, double colon, that means, oh, other 16s are all zeros. That's why it makes sense. That means 2 or more quarters of all zeros. Okay. However, you can only use double colon once in a single address because otherwise the exact IP address might not be clear. What does that mean? You have 0, 0, 0, 0, 0, 0, 0, 0, and you put double colon, and then you have some digits, let's say A, B, 0, 9, and then again 0, 0, 0, 0, I mean, yeah, and 0, 0, 0, 0, and then you put double colon again. If you do that, then it will be confused. System would be confused if you put double colon in 2 different places. So that is not allowed. You can only replace once, only one double colon. That's 2 rule. Okay, remove leading zeros. And if you have 2 or more consecutive hexes with zeros, then put double colon. Rule number 3 or within number 2 is that you can only do it once. Okay, good. Let's do this. See that? Now you know. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Oh, this is 3/4 of 0. So which one do we choose? That's where the problem is. You don't know when you're going back. When you are recovering it, you don't know. If you put colon here and here, you don't know when you're putting it back again. You don't know if 3/4 came from this side or this side. That's why you cannot use double colon twice. Okay. And it will make sense now. So first we did what? Look, F E00, there's nothing we could do, right? The leading zeros can be removed, so there's no leading zeros. Here you have 0, 0, 0, 0. So this guy is doing just writing out instead of 40, remember? Instead of 40, you can write 10, you cannot remove everything. So this 0 comes here. 4, 0, 0, 0, 0 comes here. And the 0, 0, 0, 1, remove all 3, now you have only 1. This 0, 0, 0, 0 again would be just 0. This 0, 0 would be just this 0. This one would be the just zeros. And 0, 0, 5, 6, remove all both 0. Now you have 5, 6, right? We are good up to here. Let me know if anybody has any question. Now we have to take care of colon, double colon thing, right? Here it is. So this 3, we can replace this 3 by double colon, or we could do this one. But we said that we cannot put double colon twice, only one. So we decided to do the bigger one. Let's do this one. Why? Why bother writing 0, 0, 0? But this one, all zeros are replaced by only one double colon. Because we did once already, we cannot do anything with this. So that comes down here. 0, 0, comes down. We cannot do anything. So only thing we did this, double colon, and that's it, right? If you do it other way, that you did this one double colon here, and this one, if you do you have to leave it here then 0:0:0. The system will be able to recover it. That's not a problem, but problem is that it's kind of silly that why take the easy path of making this one because you have more zeros here than this one. That's the reason we decided to do this, not this. This one comes down as it is, as they are. Okay, got it? Question? That's what you're, IP version 6, the introductory IP version 6, you're going to have midterm and quiz, not today, but next week, will be similar to this. Very easy. Yeah. And then, okay, so what we did was that we shortened this one to this. Now it's easy to write. FE00:0:0:1 and then ::56. It's easy now. Some common mistake, never remove trailing zeros, of course. Right? Zero on the right side, never remove that. Right? You cannot remove zeros on the right side, man, meaning these zeros. These are trailing zeros. Only leading zeros you can remove. So it says don't make that mistake. First quarter of this cannot be shortened at all because the two zeros trail. Okay, so incorrect, right? That's what it says. You cannot write up this. Second common mistake is to replace all series of quarter with double colon. This colon and this colon, you cannot do it. And intuitively, you know, because when you're going back, expanding it, then it only makes sense when you are putting one colon, one double colon, not two. To expand an IPv6 address back into a full unabbreviated 32-digit number, use two similar rules. The rules basically remove the logic of the previous two rules. Reverse. In each quarter, add leading zeros as needed in the quarter, blah, blah. And double colon exists, count the quarter currently. Total should be. So replace this one with multiple quarters of this, either 2 or 3. You can actually do it without even reading it, right? It's so intuitively correct. Like this one. Now you're going back. So I know that F is 00, I cannot do anything. I know 0 means 0000. And I know this 0 means 0000. And I know this 1 means 0001. And then I have 56 meaning 0056. So how many quarter I have? 1 quarter, 2, 3, 4, 5. But I should not quarter. It's a quarter, yes. 5. But I should have 8 quarter. So that means I'm missing 3 quarter of zeros. So this double colon means 3 quarters of zeros. Right? You can just, by looking at it, and that's what it is doing. See that? 0:0:0:0:0:0, blah, 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 and then this. And the next step is taking care of this 2 column. And said, okay, I'm missing 3 quarter. So that means it got to be 3 sets of quarter. Now I'm back to the original one. Right? Your system knows this is what he meant, but his system does further because system works with binary zeros and ones. So system will convert further F to something 1111 0 to 0000, and then it will be 132 bits, right? That's what it is now. The future is what? Quantum computing, right? That's they'll be using a different kinds of instead of binary. That's the future. If you guys, any of you wants to do higher education, graduate school, PhD, one field is the quantum computing is going to change a lot of things. the way chips are designed, the way I mean, it's gonna be faster, like 100 times faster than normal computer. So that's what is coming up, and that's where they're going to replace zeros and one. It's going to be like, I don't know, 3 or 4 dimensional ideas coming from physics. So they call it quantum computing, but the idea is taken from physics and then it will be used in computing, chip design and everything. So there'll be no zeros and one. Okay, you see that simple it is. Okay, and then we'll do a couple of them and that's it. So let's see. 2340, nothing we can do. 0000. Let me see how many sets are there. One set and then not this one, not this one, not this one, not this one. Only one set of zeros. So I can only write colon, double colon, only one double colon, right? Then 0010 is nothing but 10. And then 0100 is nothing but, remove the leading zero, you get 100. 1000, there's nothing you can do. There's no leading zeros. Same, ABCD same. 0101, remove 0. So you got 101. And this one, there's nothing you can do, right? So yeah, it should have 1 set, 2, 3, 4, 5, 6, 7, and double colon represent only one set of zeros, 1/4 of 0, right? So everything is in TD makes sense, and that's what you'd be responsible for. Question from midterm and quiz. Next week quiz is easy. So same way you can do this and this and this, but look at this one, right? Let me see if there's anything else here. So I have 1 and 2 sets of quads, and that represent 2 sets. 1, 2, 3, 4, 5, 6, 7, 8, 2 sets, right? Look at this one, this one. 3210, there's nothing you can do, 3210. And look at this, after this, all zeros. Beautiful. You put a double colon, that's it. You have 7 sets of zeros, 7 quarts of 0. 1, 2, 3, 4, 5, 6, 7. When you reverse it, there has to be 7 sets, right? Because you need 8 quarts. You can do that. And you'll see you'll do it. Right? This one, 0, 0, 0, 0, 2, and 3. So similar. This is where we're going to, oh, no, that's D. So you have 2, and you have 1, 2, or 3. So that means we're going to use this one, because this one has 3 quads. So 210F, then double colon represent the 3 sets. CCCC, there's nothing. This is 0, this is 0, and this is going to be just D. If we have, I don't know if there's any, 1, 2, 3, 4, that's fine. 3, 4, you can do that. If you have, let's suppose that you have 1, 2, 3. Instead of 3, let's suppose this is 1. Oops, where am I? Okay, let's suppose this is 1. This is not 0, but this is 1. This is 1. So what happened in this case is that you have 2 quarter of 0, and you have, what am I looking at? Oh, no, not this one. I'm sorry. This one, I'm talking about this one. So suppose this one is 1. This is 1. So you have 2 quarts of 0, and you have 2 quarts of 0. both of them. Which one do you choose? Well, choose either one. Doesn't matter. Either you put double colon here, or you put double colon here. If that is the case, then you choose whatever you want, either this or that. But in this case, because you have three sets, 3 quarts of zeros, obviously you choose 3 quarts over 2 quarts because that's easy to write. Okay. All right, so you good? Easy or not? We have 10:30. Okay, you know what? Let's take a break. Hour and a half. So we are right here. Okay, let's take a break. 25 minutes. All right. So 25-minute break. So be back at 10:25. So 10 56, 57 p.m. Okay. Okay. So see you in, I'm going to step aside. So see you in 25 minutes. Okay.
Professor,
Yeah.
I came late, so I missed.
Okay. Deal. Let me get you the deal.
I did too, Professor.
Put you there. Okay, who else came in late?
Me, Professor.
One
Kylan.
second. Huh?
Kylan.
Kellen, right?
Yes, Professor.
Okay. I got you. Okay, I got you too. All right, Samuel, are you here? Samuel is missing, and Tanvir, are you here? Robert? No, Robert? Not Robert. Is it Robert? Yeah, Robert. Robert and Samuel. Okay. See you in 25 minutes. All right. Guys, hear me? Okay.
Yes, Professor.
All right. So, let's go back. I don't know if I'm still sharing. Let me check. And sharing. This one. Okay. So, current slide. Okay. So, we covered that. So, we learned how to shorten it. And we learned what IPv6 is, right? If you go back, the basic rules, how they're used. There's some couple of slides. You just look at it, right? Remember OSPF and NTP. We understood this, how to shorten it. We did some, these are shortening process, and we did some example. Good. So you just have to know this introductory basic one, not intermediate level. But basic is good enough for you guys to, you know, if you got a job, started working, or your manager is asking you something, you should be able to answer it. So IPv6 is a mask concept called the prefix len, similar to IPv4 subnet mask. Okay, IPv6 prefix len is written as a same / followed by a decimal number. The prefix len define how many bits of the IPv6 addresses define the prefix. Right, prefix is for the network part or subnet mask. Same thing, like this, right? You can have a space between the address and this, but when you're typing the value into Cisco router, you might need to configure with or without this space. They're talking about this space. It's just saying that both might work. Okay, with or without. For example, is either of these for an address with 64 bits per pixel. 1, 2, 3, 4, 5, 6, 7, 8. All it's saying is that 64 bits. See this now. This is written in binary, right? So all it's saying that 64 bits belong to the network part or subnet. That's even for this. You got all of them. 1, 2, 3, 4, 5, 6, 7, 8. Out of this, 64 bits belong to the network part. Same as IPv4. You have to write it. Well, it's needed, then you have to write it. If it is not, then you don't have to. Same as for IPv4, you do it sometimes to define that this is a subnet or not. Okay. Legal value ranges from 0 to 128 inclusive. Okay. So you can start with an IPv6 address and prefix length. We just talked about it. Copy the first bits, change the rest of the bits to 0. Okay. I'm going to add this length. So now this is for the host, and this is for the network part, right? 64 bits and 64 bits. 32. Okay, I'm just Okay, let me see what they're doing. Okay. So they're saying that you can write this way. Address prefix. Because prefix gives you the network part. So it's same as your network ID, right? So first 64 bits belong to the network part. So in order to write it out in prefix term, you have 64 bits right here belong to the network part, and last 64 bits belong to the host part. And remember, you write the network ID, you put zeros to the rest of them, because you're only interested in the network part. And that's what the prefix means, like how many bits belong to the network part. So that means rest of them, you just write out 0, 0, 0, 0, blah, 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 all zeros. And since they're all zeros, you can just put double colon. So this is your network ID or prefix, right? So you don't have to write out this way your prefix, but you can write out this way. That's all it says. Because this is your prefix or network ID. That's it. So the same thing. Instead of writing this, your prefix would be this. Right? You write out first 1, 2, 3, 4, because there are 8 of them. So you take 1, 2, 3, 4, and the rest of them belong to the host. So you just put double colon, right? Rest of them belongs to the host. 1, 2, 3, 4, and these are for the host. You put 0, 0, 0, 0. So you take first 4 of them. Same thing, first 4 of them. You take them, and that belongs to the network part or prefix. You put double colon because they're for the host, and that's it. So same way you can do this, right? Same thing. You take this one, 1, 2, 3, 4, double clone. This is going to be 0, 0, 0, 0, /64. Same thing. Only thing is this one. We're not going to do that because these are for subnetting. We're not going to cover subnet. The idea is the same, but subnet, same idea, borrowing bits and all those things, but it's going to be a messy little bit. So we don't have a slide for that. So idea is the same, but we're not going to cover the subnet mask or IPv6. Okay. Got it? Question up to here? We covered what an IPv6 looks like, how many bits, how many hexadecimal, how can you shorten it, and how can you identify whether it's for private or public and all those things. And then how do you write out the prefix or network ID? Not much, really. Shortening is something that you have to not make mistake. Probably, I'm not sure this is the last slide or not, but create unique interface ID from MAC address. You see that? Now you can use interface ID using MAC address. So we know MAC address is something like this: 1, 2, 3. There's 3 sets of quad. So 24 bits, right? Is it? Hold on. How many bits is that? 4, 4, 4, 4, 32, and 32 times 1, 2, 3. So it becomes, is that right? 96? No, I'm making some mistakes. Okay. 48, right? 16 bits, 16 bits, 16 bits, that gives you 48 bits. Each of them is 4 plus 4 plus 4 plus 4, 16 bits, right? So 48 bits or 3 quad or 4, 6, 12 hexa is your MAC address, right? So when you look into MAC address, they always talk about hexadecimal, not in binary. And there are 4, 8, 12 hexa, or 3 quad. Using this MAC address, can you make an IP address? For some reason, you want to create a unique IP address, right? For your host. Right? So remember, last 4 quad belongs to the host. And you want to create an interface ID using this. There's a mechanism. I mean, do you use all the time? I'm not sure, but you can create this one. We have a question in your exam. Creating MAC address, creating interface ID from MAC address. How do you do it? It's easy. You split the MAC address into 2 equals 6 quarter. So this is your MAC address. You got 1, 2, 1, 2, 3, 4, 5, 6. You just split into 2. Right? So you have 0 to 1, 1 to 2, and another part is 1A 0043. Right? You split it, and then in between FFFE, put this hexa quad in between. So you see that FFFE. I put it in the middle. Split it, put it in the middle. Excuse me. Okay. Split and add FFFE in the middle. Okay. It says from the left, take the 7th bit. And invert it. If it's 0, it will be 1. If it is 1, it will be 0. So from the left, take the 7th bit, not the hexa number, but bits, binary bit. So how do you do that? The 7th bit is 1. Okay. So you see that this is 0. So if you write it out, it would be 0, 0, 0, 0. You don't have the 7 bits here. And after that, you have 2. So 2 means 0, 0, 1, 0. That's 2. Right? This is 0 and this is 2. Now I can find the 7th bit. which is 1, 2, 3, 4, 5, 6, 7. This one is my 7-bit. So 7-bit you always find in the second hexa number character, right? It's always the second one. If you write it out, which is, if it is 2, whatever it is, if it is A, find out what A is. F is 1, 1, 1, 1. So 2 is 0, 0, 0, 0, 0, 1, 0. And I take the 7-bit, which is 1, invert it, that becomes 0. Right? Now 1 becomes 0. So now what happens to this one? That becomes 0, 0, 0, 0 remains the same for 0 for this one. But 0, 0, 1, 0 becomes 0, 0, 0, 0, right? Because 1 is inverted to 0, and I have 0, 0, 0, 0. And if you write it out, the first one doesn't change, still 0. The second one becomes 0 from 2 to 0. So this one becomes 0, 0, 0, 0. The hexadigit is, of course, 0. So the unique number interface, you see, I put it this way because I cut it in the middle. So FFFE, so 2 goes to the left one, and last 2 goes to the right one. So now it becomes, first one is 0, 0, 0, second one becomes 0, and the rest is same. 1, 1, and this together is 1 quad. 2 to F, F is 1 quad, FF. And then third one would be FEIA, whatever it is, and 0043 in this case, right? So that's your unique interface ID created from the MAC address. When you actually use it, I'm not sure. But this is a way you can actually create an interface ID from a MAC address in Hexa. All you're doing, you are breaking into 2 parts right here, which is this. Put FFFE, but 2 goes to the left, which is FF, and FE goes to the right. Now you have a balance 4/4, and all you have to do is that take the 7 bits, which is always in your second hexa, invert it, in this case 2, which is 0, 0, 1, 0, it becomes 1, 0, so that means it becomes 0, 0, 0, 0, which is actually hexa 0. If it is F, instead of 1, 1, 1, 1, it would be 1, 1, 1, 1, 0, 1. So I don't know what is 1, 1, 0, 1. Right? And you just put that 1. Probably, let's say that's leading. So that means that would be, this one would be 9, right? This number would be 9. Something. Simple. Any question on this? Yes? No? Maybe? Creating interface ID from MAC address. I think that's it. No question, right? So you got to understand, remember this one. You got to remember how to shorten things, right? Or expand it. You got to remember some slides that you may not like, which are this one. But you got to remember at least OSPF version 3 and NDP. And these are all conceptual that we have done it, we have talked about it, same as IP version 4, and that's it, right? You got to remember this one. Global unicast, unique local, multicast, and link local. Okay, this is so this lecture is not And every quad defines something, identify either location or they belong to the ISP or belongs to the company or organization itself. So there's meaning to that. We did not go in details. We don't have slide for that, but don't worry about it. So first, so 32 bits. So that means first 16 belongs to the ISP. No, not ISP, but first 32 bits. So first 16 belongs to the region and ISP and all those things. And last 16 bytes belongs to the company itself. You can do subnetting, but we didn't go over that. The idea is the same, but it's kind of messy. They just said briefly that you can't possibly have private IP address, but it's not well defined. It is also possible that they may not allow private IP address. I'm not sure, but idea is that every device host will have the unique IP address. That's many you can create because you have 128 bits. And if you do 2 to the power 128, you'll see it's trillions and trillions and trillions. So if all the planets are inhabited by some form of life form in our solar system, could probably assign IP address to each of them. That's that many. So we're good for next 100 years, unless you want to have the whole Milky Way, then it's a problem. Okay. Question? No question? Okay. If no question. Okay. So you got a good idea about IP version 6. You got a very good extensive knowledge or ideas about IP version 4, subnet and everything. And that's what we're going to have quiz on right now. So make sure all your IP version 4 knowledge in front of your head. And since it's open book and everything, you can take it out. Going to set up your quiz right now. Quiz 2. But you get more time because it takes time. In-class quiz. Quiz 2. Quiz 2. What? No, this is quiz 3. IP version 6. So next week will be quiz 3, that is IP version 6. Right now it's going to be quiz 2, IP version 4. So start would be 10, 5. Let's see what time. This is 11. 11:26. 28. 11:28. Okay. 11:28. Start is 5, 11:28. So that would be 10, 5, 10, 5, and the time would be 11:30, so 58 a.m. Okay. And then end it, due date. Okay. So it starts at 11:28 and it ends at 11:58. she got 30 minutes. And I think there are 10 questions, but because, you have done the homework, so similar, so that you get 30. So you do this one for 30 minutes, and then you take another 15 minutes break. So we'll meet up 30, 40, 45 minutes after 45. So after quiz, still you get another last 15 minutes break. Okay, everybody sees it? Anybody confirm quiz 2?
Yes, Professor.
Okay,
I,
great.
Yes,
I
Professor.
see, I see it. In class quiz.
Yeah, you should be able to start. 11:28. It is 11:28. October 5th. Okay,
How do you initiate it? Because it's,
you
Yeah.
just click on it and it will start.
okay.
If you click on it and
Okay, I got it. Thank you.
got it. Okay. So all right. I'm back. Let's see how but this is probably a little bit harder quiz. If you have not done first to lecture properly a lab, but if you did, then it should be all right. Test out, test out. Class quiz. Actually, everybody did well. Yeah, everybody did good, actually. A lot of 90s, even some 100, some 80s. Only a couple of people did bad, but most of them did actually better than I thought.
Professor, real quick, are you able to open up the report for the quiz to see what is it that we got wrong?
Which one he got wrong?
Yeah, usually on the quiz section when you click the report, it shows you which one you got wrong, but I couldn't see it.
You couldn't see it?
Yeah, I cannot.
So you didn't probably select the option when you started the quiz. That probably has an option. But
It's the same thing for quiz one, you can't see the report.
You can. I don't know if I don't know if I can make this option available. I'll look into it. Let me see. I can quickly do it. These two. You cannot see it, right? Number 8. I think the number 8 is answer wrong. You got number 8 wrong. You said one subnet with 254 hosts. The answer says 256 subnet. That is not true, actually. Let me check others.
That don't sound like the quiz that we just took.
Yeah, that's the quiz you took. No? Yeah, quiz 2.
Quiz 2?
You took quiz 2, right? Quiz number 2.
Yeah, that's the only one that was available for everyone, right?
That's the only one available for everyone. Yes.
Professor, as kind of like a quick question. It says I submitted it 224 days late or past the due date. Will that affect my grade?
The quiz?
Yeah, quiz 2, model 3.
224 days left?
Yeah.
Really? Why is that? Did it say for anyone else? 224
I
days
put it in the
left.
chat.
Yeah, for me too, it says that.
Oh,
That it's
really?
like
Maybe it was set up for last year and never probably updated it, I guess.
That wouldn't affect our like grade though,
No,
right?
no,
Okay,
that
okay.
would not. That would not. 256 subnet with the network this time is sort of available. Oh, no, that's right. This is
Professor, I took the wrong quiz. I took 4 instead of 2.
4. How
Yeah.
can take 4? 4 is not available.
Yeah, it was available. I thought I clicked on 2, but I clicked on quiz 4. All of them look
4.
like they're available.
No, 4. Hold on a second. 4 era, right?
Yeah.
I don't think so. Let me check.
Yeah. Quiz 1 through 5 is available.
Quiz. Oh. No. How did you even take quiz 4? Interesting. Quiz 4. Ugh. How did you take quiz 4? Let me see.
Yeah.
Let me check. I see that you did that, but I just don't know How you got to quiz 4? Let's see. Quiz. In class quiz. Quiz number 2. Due 25 minutes ago. Quiz 3, quiz 4.
Professor, it said I submitted an hour after the due date.
You submitted an hour. Okay, that is not a problem. It's just the timing. Don't worry about it. I'm just worried about Ira. You took quiz 4. Right?
Yes, I thought I clicked on 2, but I guess I clicked on 4.
Yeah, but why click March 8? March 8. It was available on March 8. How could you take 4? This is impossible.
Yeah, I thought I clicked on 2. But it's...
That was available on March 2, 2025, March 8. Now it's confusing. Quiz 2.
Is it possible to take quiz 2?
I have to set it up for you. I have no idea how you got to 4.
It
But
shows that
since-
it's available.
Yeah, but since you actually did, I have to set it up for you. I just don't know. I have to figure it out why you got to that, but I see it that it took. I'm going to check it again, unless I'm making a mistake. Quiz in class quiz. Quiz 2, quiz 4. Era. Now everybody else, whether you it shows that you submitted 200 days later or half an hour late, that's not a problem. I see all of it, so you guys are good with that. That is not a problem. I just have to see, maybe it was created in 2024 and maybe I have to update it. We're using Brightspeed not long ago. It's been probably third semester, second semester, so maybe something else I have to do. But everybody else is fine except Mr. Ira. I don't know how, but I have to, because let me set it up for you. You want to take 2? Now or later?
Whenever's convenient for you.
No, now we're going to do the lab. So
Okay.
you want to do after lab?
Okay.
Okay. Just remind me.
No
Okay,
problem.
everybody else is fine. Why cannot you review? I don't know, but I can review it for you guys in the next class. Okay. Let's go to lab. But everybody did well. There's always, there's always a question that is confusing. And if it is so, then, at the end of the semester, I give extra points to everyone. If I feel that, some questions are not fair or confusing. I don't like confusing question myself. If I see it, I'll add points to everyone. So that part, don't worry. I see one question may be confusing. Okay, so lab, we are at lab number 4. No, lab 5, I guess. Create a simple network using packet tracer. Okay. So let me share my screen. Then I'll go through that, what they're saying. Submitted 224 days late. Past due. Okay. Share. Okay. Share button. Okay, I'm gonna have to share my screen. Sharing screen puts everything here. So lab, let me go there first, so you guys know what I'm talking about. So this is lab 5. And packet tracer, create a simple network using packet tracer. Is that the one? Hold on a second. Oh, no, not this one. I'm sorry. It's going to say lab 6. Do you see it? Creating LAN with router. You guys should be seeing this one. Yes? Lab 6. If you click on it, there's a simple document. So it's going to change the direction a little bit. Simple document. And if you open it up, so your boss comes in and says, hey, create this one. You know, there are a bunch of computer. And this is probably, let's say, you know, this one is connected to, you know, marketing department. This is connected to product department, and then put it in a router this way. There's no, you know, sometimes they don't have much description at workplace. And they said that you have all the IP addresses, just create this one. They said, okay, boss, we'll do it. So design the following network and submit. So this one is just one page. You see, there's nothing else. You create it and submit. So what we did here is that I have 1, 2, 3, 4 devices connected with a switch. On the right side, you see the same thing. Now we are back in packet tracer again. On the right side, you see the same thing. Oh, there are 3 of them. And I have added 192. So this is an IP address, right? 192.168.1.1.2.3.4, right? So so you see that this is a private IP address, right? Anything start with 192.168, you know it's a private IP address. Anything start with 10, that's a private IP address. See, on the right side, I also intentionally used private IP address, 10. So 10.001, 10.002, 10.003, right? 10 dot and 192.168 are heavily used for as private IP addresses. And with this one, left hand and right side, they are all connected to a router. They all have to be connected to a router because router needs to be configured. So you see that this one is connected to Gigabit Ethernet 00. And this is the IP address, 192.168.1.254, right? This is the IP address of the router, and it connects it to GI00, and I'm using 2911. The boss gives you everything. On the right side, it doesn't give it to you. So I didn't give it to you because I want you to think about it, that you need an IP address. Either you ask me or use a reasonable IP address. So if this is 10.0.0.1 and 2 and 3, this is possibly 10.0.0.254. Right? So make it consistent. On the left side, 192.168.1.0. So on the right side, let's be consistent, 10.0.0.254. That's the gateway address or router interface address. When they say gateway address or router, they say it interchangeably. Actually, gateway concept is a little different than router, but they are packaged together. Router has the gateway capability. Right, so gateway address, router address is the same thing. So I didn't put it there because I wanted you to figure it out that there's nothing there. So if there's nothing there, no IP address there, what happens? Any data you're sending to the right side, you won't be able to pass. So I'm just telling you that even if you don't listen to me, then you have to figure it out on your own. And if you don't, because there's none there, then you should not be able to ping. And you should think about it. And if still you don't care, then you're losing points, right? So network ID on the left side is always what? This is class C, right? 192.168.0.1.0, right? Network ID, the host part is 0, remember? Class C. Class B, if it were class B, let's say 190, what is class B? See, I look for class B is 12126, right? 12126.77 is reserved. Okay, so 128 on is B, right? So if it was, let's say 130, so that would be 130.168.0.0, right? Remember the way you write network ID? So this is fine. There's no subnet. This is the network ID. On the right side, 10.0.0 is 0 because this is class A. So network ID is .0.0.0 and prefix is 8. On the left side, prefix is 24. So far, so clear? Now, these are all static IP address given. All you have to do is that assign this one 192.168.1.254. So 254 is you can use any IP address, but it's customary to use 254 because 255 is the broadcast address, right? So right before that, they use their address for the interface or router. When it's a router address or gateway address, it is actually the interface address right here, which is GI00, this particular port. All right, so you can use anything within this one. So you can use, .1.1 or .1.2 or .1.3, but you have used already .1.1, 1.2, I'm sorry, 1.2, 1.3, and 1.4. You can use 1.5, but maybe you'll use 1.5 for another device connected, another device. So that's why it's customary to use the last one right before the broadcast address for the interface of gateway address. That is not necessary. Somewhere you go and work and you'll see that they're using some number that is not .254. So what are you going to fight with them? You just use that. Okay, so I'm going to do a couple of them and then you do the rest. So, I have two, what switch is that? I have 2960 to 11. So 2960 and router I'm using 11, this one, okay? and I'm going to use device, you have to use 4 of them. So I'm going to use, on the 2 on the left side instead of 4, and I'm going to use 1 on the right side instead of 3. Okay, so let's connect. This one goes, oh, I'm sorry. This is going to be straight through, right? Not crossover, straight through, because they're not similar, dissimilar. So you connect to 0, 1, and then you take this one, not crossover, this one. You connect to 0, 2, and then you go to, again, this one, and then you connect to first one, right? This is another, switch that we're using, and then you have to connect this one to this one, switch to router. This is also straight through, because switch and routers are not the same. So that's why I'm using straight through. So take whatever you want, right? I used up 1, 2, so 3 is available. I'm going to use 24. Okay, I just chose 24. Why? Because I want to leave others for anytime you want to add devices. I want to leave 1 to 23, because after 23. Now this one already given. Use gigabit Ethernet 00. It's given in the schematic. So I'm doing that. For this one, now crossover straight through again. And I'm going to use same, you can use anything. You're not going to lose point, but it's customary to use the last one, 24, because you want to leave everything else for devices that you want to connect later. This one, I didn't say anything over there. But the left one, I use gigabit Ethernet 00. So you should also use gigabit Ethernet. Some routers have fast Ethernet. But because you're using one side gigabit Ethernet, then other side you should use the same. Otherwise, it's going to be slow. So it's meaningless to use gigabit Ethernet one side and fast Ethernet other side, because then both have to use the lower one, right? So that one you have to make sure. Otherwise, it's a waste of that particular cable. Gigabit Ethernet cable is more expensive than fast Ethernet. It's not only the port itself is expensive, but the cable itself. So now I have connected this one to 00, which is this. See that 192.168.154. This is the IP address, but I'm connecting to GI00. I just did. This one is not given, but I have to use something. So I used gigabit Ethernet 01. These are connected. This is not connected yet. It always takes a minute, right? So I got this. Now what do? I go to this one. I have to add the IP address. So you do config, desktop, and then IP config. And your IP address is, see that, this one? 192.168.1.1, Class C private IP address, 192.168.1.1. And if you just hit enter, your subnet mask will appear by itself. Now here it is connected to a gateway. See that default gateway? So you got to enter the default gateway, because it is connected to a router. And what is that? 192.168.1.254. We're not connected to any DNS server. It's a name server, right? If you have a name server and if you put, if you put, let's say, yahoo.com, then it will translate, where yahoo.com is or Microsoft.com is. So you have to connect it to, you have to give an address to the DNS server. And if you do, then this will go to DNS server, resolute the IP address or name to IP address. And that's, that's a simple thing. So that's why. So here we're not using that. Okay. So this is my 192.168.154 is my default gateway. It is given right here. You see that? Where is that? It was right, isn't it? No. This is the one that I'm working on. Okay. Let me, I got this number from there. Okay, now I go to config. Oh, I have to take out this. If you click on web server, and that's where you put URL, Yahoo, let's say yahoo.com or Microsoft.com, and it will go there, right? Assuming it's connected to a URL, I mean, that particular server is alive. Now over there, you put a DNS. So DNS can find out. So if I say yahoo.com, then you need to put a DNS address, an IP. Let's say, it's within your network, right? Within network, you have a DNS server and you put, your boss says that, well, this is 192.168.1.50 is your DNS server. So if you put there, it's going to go there first and find out if any script is running. It reads it. Sometimes it loads a lot of things. And then it's going to resolute yahoo.com, find out the IP address, and it knows this is the IP address Yahoo. Then it's going to tell the router, hey, we got to go there. Whenever somebody types yahoo.com, okay? But we're not doing it. I'm not doing it. I'm just telling you that that's what this DNS is for. Okay, we're not going that far in this course. Okay, so I have this. So what I did is that I came here, I put the IP address, subnet mask was entered automatically. Default gateway is something I put it in because it was given. You don't have to put OK or save or anything. You close it and you're done. This is the IP address. See that? 192.168.1.254 is the gateway address. Is also the router address. It is also this interface address, interface TI00. So I'm done with that. So you go to desktop, IP configuration, and IP address would be 192.168.1.2. This time is .2, it's the second one. And your default gateway is the same thing. 192.168.1.254. Okay. So I did that. See, in your final, they're not going to be GUI to do these things. But now we're showing you how it is actually working. From now on, you'll be using all command line interface. But because of the concept, we're showing you this. So this is done. I did 1 and 2. I did both of them. Now, I did not configure this router interface, meaning I need to tell the router this interface has this IP address. So how do I do that? I probably have to go there and config. See, that 00 is the one. This is the one. So IP configuration, IP address. What was the IP address? 192.168.1. What is that? 254, right? So you see that? This is the IP address of the router for the interface 00. I entered the same IP address in the device itself, in the computer itself. And I said, this is the gateway address. Now that I'm in the gateway, I did this by default. Remember, by default, the port status is always off. Because you are working on it, they want to make sure that nobody's trying to go through the system. So they, by default, they disable it. We'll learn all about enabling it through command line interface. So for now, if you did everything and if you don't enable it, you will not be able to ping and go on the other side, right? So if you're not able to ping, you come back here and you said, enable it. If I click on, it will be enabled. And here you'll see, it will also tell you the command that you used. So let's see, if I do this on, you see it's change. All it did is that in the interface is a no shutdown or no shut. No shut meaning enable it. Shut meaning disable it. Right? They made it so easy. No shut or no shutdown. It's enable. So I did this part. Now it's supposed to turn it green. So I go to this one, and then I do configuration. This is 10.0.0.1.1, right? And gateway would be 10.0.0.254. Yes? 254. Good. I just added the IP address 001, and this is the default gateway that I didn't mention it in the diagram, but I said that, you should figure it out. So I figured it out. So I did this one. So this is green, so I did it right. So I have to do the same ping on this one, 201. See, how do you go to 01? It's going to show you right here. So if anytime you forget any command, not in the exam, but other time, you use the command line interface, not command line interface, the GUI, click on it, and it says how you actually did that. You type interface, then GI00. It goes to 00. But we already did 00, so I want to do 01. And it says interface gigabit Ethernet 01. I usually type INT for interface, and instead of typing the whole gigabit Ethernet, I just type GI and then 01. We'll do that, don't worry. We're not there yet. Okay, so I put the IP address. This is 10, right? On the right side. 10.0.1.254, right? Yes? Everybody agrees? Good? Okay, turn it on. I turn it on. So they're supposed to turn green. If they're supposed to turn green, I can ping from this one to this one. And if everything is right, I should be able to ping it. So I wait 1 minute to turn it on. But let's go there if I want to ping it. If I want to ping it, you go to command prompt. And it said ping. Let's do the pinging within that one. 168.168.168 what was that? Dot one, dot two. I'm pinging from one, I'm pinging to the next one, and it should ping. You see that? You're pinging and sending 32 bytes 4 times to this one, 192.168.1.2, 4 packets sent, right? 1, 2, 3, 4. 4 packets send, receive 4 packets. You send 4 packets, you receive 4 packets, then every time it sends the acknowledgement and it's a 0 loss. So ping command basically tells you, are you alive? If alive, then I'm going to send you some information, something like that. It also tells you how long it takes in millisecond, right? So I did fine. Now let's ping on the other side. 10.0.0. I think it was 1. And then you ping it and you wait and it's a timeout. That means first byte was sent timeout. It did not give any reply. Oh, second one is gone. Sometimes he give you like 3 packets reply and you do it again and then it will send you all. This time does not look right. It says lost four of them. All 4 packets are lost. 100% lost. So I go back and I see what's going on. It says green, but it could not ping. So I go and look everything. I
Professor,
put my mouse over this. Yeah,
I see you use the crossover wire
I
on
did. For
on
which
the
one?
right side.
I did? Okay.
Yeah. And I
Okay.
think the IP address you did 10.0.1. I think it's
So you've
10.0.0.
hold on. What's your name?
Robert, I don't believe you
Robert.
paid for attendance because I came a little bit late.
Okay. So this one you said I did it wrong, right?
Yeah.
So I'm gonna take it off. If you're right, okay, doesn't matter what I put in, but I assume that this one I didn't do it intentionally. So I probably did it unintentionally. Okay. So, but I take your word for it, straight through. Okay, so fast Ethernet, and this is going to 0, 1. Yes. So Robert says that I made a mistake, and if I did, I didn't do it intentionally. However, Robert, you also pointed out that this address is wrong, right? The IP address?
Yeah, I believe it's supposed to be .0.0.
Yes, I did it intentionally. This one I did it intentionally, but none of you told me that time. So this one actually I did it intentionally because they are not in the same network. If you put .10.0.1, they are not in the same. If you put 1, that's a big problem. That's a big problem. If you put 1, that's a big problem. So they are not in the same network. This is the same network because it said network address is 10.0.0.0. So what I had 1 is wrong. And I did that intentionally. Now I'm fine. I want to make sure everything is on. So this one is on and port status is on. Bandwidth is auto. So if you use gigabit Ethernet, it's actually this one, 1000, and 100 would be fast Ethernet, right? So if I put auto, then they said, hey, you're using gigabit Ethernet, I'm using a fast Ethernet, so let's just use 100 megabits per second. Take the lower one. So you don't have to, have a clash. But we are using gigabit Ethernet for both, so it will transfer data at 1 gigabits per second, right? Both of them. This one and this one, both of them I'm using gigabit Ethernet. So this time, if it works, fine. If it doesn't, then we're in trouble. But let's see. Ping. Oh, I probably have it on. Yes, 10.0.0. Let's see. Looks like we're good. So I made two mistakes. One that I used the wrong cable, another one I intentionally put a wrong IP address for you to detect my mistake. But maybe some of you didn't tell me. But Robert was brave enough to tell me. Okay, good. This is a simple thing. All we learned is that you need to add the gateway address in each of the devices. And you need to add the gateway address in gateway itself, gateway router itself, for that particular interface. That's how you define that. So now it knows. This knows that it goes to the switch, and then it's connected to this router, to this one, right? Because that's what this guy tells. Go to this interface of this router, because you can have multiple router connected. And then it says the other interface is 10.0.0254, and it goes to the particular device. Okay, this is easy. You can finish it off in 10, 15 minutes, 20 minutes. Make sure you use the correct IP address for the left one and right one. You don't have to level these things the way I did. If you do it, that's good. That's like you're doing it for your boss. You can level. You can. I think you can level somewhere. Yeah, I have done it, but is it this one? Place note. Oh, yeah. So you can do it. 192.168.1.1. I'm not going to penalize you for this, but if you do it, it's fine. Otherwise, that's not. This is for this IP address for this one. Okay. So, any question? Simple 15 minutes, 10 minutes left. Okay. Open it up, finish it, save this one, and upload. Whatever the lab is, it's lab 6. Lab 6. That's the one available. If any question, let me know. You're welcome to finish it here. Or if you want to finish it at home, then you're welcome. Make sure you submit it by Saturday night. And in this case, Shobik, you said the DNS gateway is same as IPv6 for address. DNS address gateway. DNS gateway has a different IP address, and DNS server is also connected to the switch, and it just goes to the DNS to figure out the IP address of a destination. If you write it in terms of, name, like Microsoft.com. And DNS also runs a lot of script and gives a lot of information. DNS is domain name server. Basically, it was created as a domain name. So your domain name is, Microsoft.com, right? Not your domain name, but that's where you want to go. No, your domain name is, let's say Microsoft.com. The DNS server is used to find out the IP addresses. So DNS server every now and then updates his table and find out the IP addresses that he used. If he cannot find it, it goes to the central DNS server. I don't know where it's located, probably somewhere in Washington, DC or Washington, or wherever they, whenever somebody register and there is a centrally located server, they go, and if you type, let's say, whatever, mychicken.com, and chicken was never registered and today was registered, and then you want to go to chicken.com, your system goes to DNS server, does not find chicken.com, it goes to find the centrally located server and say, what is this chicken? I don't even have IP address. They say, here it is. Chicken.server is registered in IP address 200.3.5. blah, blah, blah. You come in and you put it in your table because maybe somebody will use it again. So this is a different one. Okay. Any question you can ask me, but whoever is leaving, have a great rest of the weekend. Okay.
Okay, Professor, this is Ira. Is it a good time to take the quiz now?
Yes, yes. I still don't know why it happened, but yes. Hold on a second. mm,
So you said you'll go over quiz 2 next class?
No. Ira somehow got access to quiz 4, and that is not supposed to be. So I have to just set up quiz 2 for him. Everybody else is fine.
No, that's
You
what I'm
can go
saying.
home.
Like, you'll go over it because I had asked earlier, but I think you probably missed my question about seeing what I got wrong.
You got wrong with one question, number 8. So that's what I saw. And I can go over that if you can wait.
Yeah, of course.
Okay, so let me first set up for with router. I don't know how to set up. I knew how to do it in blackboard, but let me see. No. Was left 4. No, sorry. Look at a quiz. Quiz 2. So quiz 2. Start class quiz. Can set it up here. So maybe you can set it up here. If I add that, if I set it up here, and topic. So So release condition. Maybe that probably ought. No release condition. So, checklist. Great quiz survey. That is not good. This is one. This is not as easy as the 10. Yeah. So that is 140. Okay. 10.5. Okay. It. This condition. Oh. Indeed. I did it. This is not good. Everybody will get it. What happens then? Let me do this. This condition. Class list component. Grade quiz. No. So exempt. Except this. Era, right? Or IRA, what do you say?
Ira, yes.
So, I haven't done it. It used to be easy on Blackboard, but I'm doing it a different way. Exempt. I don't know if it is going to work this way. Exempt this, not that.
The quiz 2, module 3 is showing available for me to click
Okay,
on.
can you take it?
Let me try.
Yeah, it should start at 1:10.
1:10 p.m. All right. It looks like it's letting me.
It will?
Yeah, I'm in.
Okay. All right, go ahead. Good luck.
Thank you.
I'm going to look into the other thing, but just give me a second.
Professor,
Yes.
this is Robert. I just wanted to ask if it's possible to add me on the attendance for today.
Robert, right? Okay.
Yeah.
Hold on a second. Lab. No, not lab. Quiz, in-class quiz. Okay. So this is quiz 2. So these are all exam. What happened? Why is this exam? Samuel is not here today. Oh, maybe that's why. Oh, God. Not here. What's your name? Robert, right?
Yeah.
Oh. Okay, it's Samuel is not here. Robert. Okay, Robert, I got you.
Okay, thank you. Have a
Okay,
good day.
thank you. All right, now you want to know the six. What did he six and two do? Okay. You wanted to know the which one you got wrong, right?
Yeah, just was curious.
Angel? Yeah.
Yeah.
Let me see. Let me see. Sometimes things are confusing. So quiz two. Okay. Quiz two. Oh. What happened? Oh no. Oh no, this one. Okay. Each one is 10%. Let me see. So this network. 256. Yeah. So this is what you got wrong. No, the question is fine. You just made a little mistake. And I'll show you, okay? Just give me, you made a little mistake. It just,
Yeah, I got you.
I know what you are looking into. So, but where is it? Okay, share. I'm going to show the application. Okay, so this is the question you got it wrong. Question number 8. So it's not tricky, but you looked at it in a different way. You have the network 172.16.10.0, right? And you probably thought this is class B. How many subnet? Question is that how many bits you're borrowing? You probably thought that we are not borrowing any bits, and you put one subnet. That's probably thought. But here is the trick. I don't know, it's not a trick really. You forgot to look at this one. I don't know if you did or not, but the prefix is 24. This is class B. 172 class B, and and prefix is 24. It's supposed to be 16, but because it's 24, that means you borrowed all 8 bits for subnet. How many subnet can you make with borrowing 8 bits? 2 to the 8 is 256. You got it?
Yeah, I'm following along.
So you borrowed 8 bits, 2 to the 8 is 256. And subnet is, of course, now you borrowed it from the third octet, 8 bits, you got 256 because 2 to the 8 is 256. Now you have only fourth octet left, which is 8 bits. To 2 to the 4, 2 to the 8 is 2 to the 8 minus 2, right? So your host is 254. Your host is right. he gets that one right. But this one, he put one subnet. Is true. This one have been true if this was class C. Suppose this is, let's say, 194 right here. And you have 24 right here. So you know, oh, okay. This is a class C, and class C should have 24. I have 24. I didn't borrow any bits. This is whole one subnet, right? 2 to the 0 equals 1. Remember I was talking about, like, you know, this question I don't like, but 2 to the 0 equals 1. Then your answer is right. If this was indeed class C.
But since it was
But-
class B, that's why the answer would be D.
Yeah, because it's class B, you overlooked this 24. Or you thought that, you know, this is probably right. You didn't think, you know, that this is class C.
Yeah, because
So this is
that was
this is like overlooking, you know.
yes. Because I
Yeah,
just
it's not that you did not know, you knew it, but you overlooked it.
yes, I only
So
focused
this-
on the last 2 digits.
Yeah, yeah. This is, you know, you can say that there's nothing wrong with this question, but you can also say that this is a tricky question. You can argue that, but you know, that it just, you have the knowledge, you just overlooked it.
All right, awesome. Just wanted to confirm. Thank you then.
But you know, I take a note of it. You know, anybody has, you know, this kind of issue, I usually add points
Yeah,
at the end of the semester. But
it's
you
not
brought it
it's
up,
not
you know.
focusing on the prefix, but also like what type of class it was.
Yeah, yeah, yeah. I'm pretty sure you overlooked it. You knew both. You knew that you have to look at it. You knew that you have to look at it, but somehow you thought it was class C.
All right, awesome. Thank you.
All right. Thanks, Angel. Okay. Bye.
Wait, Professor, I had a question on that.
Tell me how's it going.
Okay, how are you, Professor?
Good. Are you doing everything on test out?
Mm-hmm. I did the last one, 4.1 to 4.4.
Good. What is your interest? Do you have interest in networking or coding? What's your interest?
I mean, I don't really have a specific
Okay. You're
yet.
open.
Yeah.
Okay. You're open. Make sure that you learn everything in this course. Try to get the certificate. IP version 4, master it. You know, go over. You did good. You did good in your lab. So, you know, it should be fine. Okay. Tell me.
I was the question from the quiz. I also got this wrong, but the way it's because it's class B, right? So that's why it's 16 network bits,
Yes.
right?
So, but you got it. You got that now.
Right. So
Yeah.
since it's 24, you have extra 8 bits from that's borrowed.
Yes.
So it's
You
2
have to
to
say,
the
this is how I
Mm.
think. I said, I look at it and I say, okay, this is class B. And then I
Mhm.
say it in my mind, it should be then the prefix should be 16. And then I read through and say, oh, there is a 24. So that means this guy borrowed 8 bits, right?
Mm.
So that's how you should like analyze it in your mind while you're reading. So it's not really a tricky question. It's just trying to mess up your mind. So I think you got the same problem, right?
Mhm.
Let me see what he did. How he did it. This is quiz. This is quiz in class quiz 2. This is quiz 2. Oh, maybe so you got the same one wrong?
Yeah.
Okay. All right. I put it in my notes that you and Angel had the similar problem. So, you know, I usually add some points at the end of the semester. This is a, you know, it's like overlooking of it, you know, partly a little bit, I'm not gonna say carelessness, but it's just overlooking it. Tanvir, what's going on? Tanvir, are you here? Let me see. But don't worry, you're doing fine. I mean, and I made a note of it. So, Okay, maybe he's taking it. Got any more question?
Not as of yet. I'm
Okay.
still reading the lab, but I'll let you know if I have any.
Okay, all right.
Mm.
Hey, Professor.
Yeah,
I've been having internet issues since the morning, so I think I missed attendance earlier. I was just
okay,
wondering if I was,
okay.
yeah,
You
I was,
taking the quiz?
yeah, I just took the quiz because
You just took it?
yeah, I just took it.
Tanvir, okay, hold on. Let
I
me
was going in
do.
and out of Zoom. I don't know if you realized, but I left a couple times.
Yes, I actually saw you. I saw you.
Yeah, I had to
I
leave and
remember
going back
seeing you.
in.
I don't know if yes, I actually, yeah. Okay, you're in.
Thank you, Professor.
Okay.
And I just want to know what section do we have to do for test out for this
So
assignment?
test out, I put it in a chat. Look at, oh, can you see the chat?
I can't because I left
Oh,
in
okay,
and
okay.
out.
Let me, yeah, because you joined later or maybe having trouble. Okay. Let me copy paste from the chat. Here we go. So I'm putting in the chat and what it says is that it says homework test out module 4, 4.7, 4.5 to 4.7.
Okay,
The
so
rest it says 4.78, DHCP, DN. These are just important topic within that module. But
okay, got
basically
it.
you have to do 4.5 to 4.7.
Okay, got it. Thank you, Professor.
You're welcome.
Hello, Professor.
Yeah.
Hello. I don't know if you remember, but then I told you I had to leave the country for some weeks.
Oh, yes, yes. Long time ago, told me, yes.
Yeah, I came back Friday. Came back Friday, so I wanted to ask you if I could. I think I missed like maybe 2 or 3 labs. And
You missed 3 lab.
yeah, and the test outs as well. I wanted to know if I could have like maybe like some 2 days to do all those labs.
How many labs you missed?
I missed 3.
Which one?
The first 3.
First 3. Okay, that's it, right? Anything else?
What lab are we on now? The second 4. Like we're on lab 4.
We are doing lab 5, I think.
Then I missed the first 4 rather.
You missed the first. Oh, all of it.
Yes, please.
Okay. All right, let me hold on. Let me open it up. All 4. Lecture packet test. Okay, you got to finish all the test out, right?
Yeah, I'll do that too. Where's the test outs? It's in the content section?
Test out what?
For the respective lab reports.
No, did you sign up with test out?
I
Hold on a second.
was it test out?
Let me see
I
if
did.
I have it.
I did.
You are
That's it.
Henry, right?
Yes, please.
Oh. Oh, no, no, no.
I did not.
You did not. You did. Your name is
Oh.
not there. That means you have to sign up with them and then you have to register for this course.
Okay. I'll
So
do
you have
that.
to sign up. When you sign up, then you register, and then you have to pay for the test out.
It's not free anymore with the if I logged in or sign up with my CUNY email.
You can sign up with your CUNY email, but one thing is to sign up, and then second is to buy the course,
Okay.
right? And then add this course,
All right.
CET4773 / my last name, Alam. You have to add it.
Okay.
Or activate that one. I don't see your name. That means you didn't sign up. Do it because you got to finish up all the homework.
I'll do
Right?
that.
Are
the labs on test out as well?
So the packet tracer lab is in Brightspace.
Okay.
The test out lab, the test out quiz or lab, they're in test out.
Okay.
So you're dealing with two things. One is that find the packet tracer lab, 4 of them that you did not do.
All right.
In Brightspace, and then you go to test out, sign up, buy the course, I don't know, 100 something, and then you do all the test out lab and quiz. And what
Okay.
I'll do is that
I see the first 4 labs are I can't access them for the packets.
for which one?
For
First the lab,
1
right?
to 1 to
Yeah,
4.
because they are gone. So
Yeah.
and then let me do that. I'll give you 3, 5. I'll give you until because a lot of them I'll give you is until Saturday. 11. Okay. Okay, so have this one, 10, 11 update. So you'd be able to see lab 1. You should be able to open it. Right? 5.
Yeah, I see 1.
You see 1, right?
Yeah.
And then you should be able to see. You should be able to see number 2. Should be able to, yeah.
E2.
You see it, right?
Mm-hmm.
And then you should be able to. Where did you go? Europe?
Ghana, Africa.
Ghana.
Yeah.
Ghana is one of our Secretary General of the United States was from.
You said
Right?
one of our what?
The Secretary General of the United Nations.
Mm.
Right?
Mm.
Do you know?
Mm-hmm.
Do you know
Yeah.
that?
Right. Yeah.
His name was I think he just passed away a couple of years ago. His name was
Yeah, the former Secretary General.
former Secretary General.
Yeah.
Very good guy.
I forgot his name too.
And this is lab 3. I put 11. How about the others? Lab 1, no, lab 3. Lab 3. Lab 3 should be able to see.
Excuse me, Professor.
4, yeah.
This is Ira. I completed the quiz.
Good.
Thank you.
All right, thanks. Good job. Okay, so we got 10, 11. And then ended is 11. So you should have 1, 2, 3, 4. Okay. Now,
Yep, I see them.
one more thing I'll tell you is, let me share my screen. You gotta take a screenshot.
Okay.
Let's take a screenshot of these things. Okay. I'm gonna go and then you take a screenshot because you gotta cover a lot. Okay, so take a screen, or you can just write down whatever, that this is the one from test out 2.1, 2.2, 2.3. That's the only thing you need to know that you have to do it.
Okay.
Okay, from first week. Okay, so either take a screenshot or write it down. That's the first week. You got
Okay.
it?
Yeah, I'm taking screenshots.
You took it already?
Yes, I have.
Okay. This is week 2. You can take a screenshot. So
Okay.
two was 2.4, 2.5, 2.6. Good?
Yeah.
Okay. Week 3 was module 3. So everything on 3, chapter 3. Chapter 3, module 3, whatever they call it. Okay.
Okay.
Got it?
Yeah.
Week 4, module 4, 4.1 to 4.4.
Okay.
Got it?
Yeah.
5 is this one, that one just assigned. 4.5 to 4.7. I just pasted on the chat.
Yeah, okay.
This is the last one.
Okay.
Make sure you sign up and do all those things. It's gonna take time.
I will.
Okay?
All right. Thank you, Professor.
Yeah.
Have a good one.
All right. You take care. Okay. Okay. See what this guy has. 3, 4. Yes. Quiz 2. Ability to quiz. Okay.